Hi everyone, we're going to find the horizontal asymptotes. Horizontal asymptotes are just, these are rational expressions here, and horizontal asymptotes are just lines. So when you're graphing things, first of all, you can only have one horizontal asymptote. So if I have a horizontal asymptote, say at x equal 2, this is y equals 2, then the graph might look something like this. It means this graph usually, and this is for college algebra, so we're not going to get into sometimes it crosses, but it kind of serves as a framework for how to draw graphs. This video we're not drawing graphs, so there's the rule you need to know. For horizontal asymptotes, if the degrees in the numerator, and that the degree means, the polynomial means the biggest exponent. So the biggest exponent in the numerator is 3, and the biggest exponent in the denominator is the same. So if it's the same, we really don't care about this right here at all. All we're going to do is take the lead coefficients, so like that would be a over b, or you can call it anything you want. And so for this one, a horizontal asymptote would be y equals 7 over 2. Okay, for this one, look at our degrees. The degrees are the same, so we don't care about all this. We really don't even care about those anymore. And what we have is, so you might have a 1 there. They don't put the 1 if there's not one. So basically, the horizontal asymptote there would be y equals 1/2. And the same thing for this last one. Our degrees are the same. We don't need to know those. So since there's nothing in front, that would just be, you could say we're multiplying by 1. So our 1 divided by 1 is just 1. So those are horizontal asymptote. This is where the degrees are the same. So you have to divide the lead coefficients, like something like a over b. Now, the second column, we have where the degrees aren't the same. In fact, let me erase this. In fact, you need to recall that x to the 0 equals 1. So if I multiply 1 times x to the 0, x to the 0 is just 1, so that's still 1 over x. However, this one is the degree is 1. So if you have the degree in the numerator is smaller than the degree in the denominator, then that would mean that it's automatically y equals 0. That means it goes right on the x-axis, the horizontal line. All right, same thing with this one. I can write this as x to the 0 because x to the 0 is just 1, and 1 times 2 is just 2, so you have the same thing. But if you notice, our degrees are different. In fact, the numerator degree is smaller than the degree in the denominator. So that automatically means it's y equals 0. And for the last one, all this other stuff, we don't really care about all this. So when you get into pre-cal, you'll talk more about limits and why this works. But this is just a basic how-to right now. So basically, the degree in the numerator is smaller than the degree in the denominator. So that means the horizontal asymptote is y equals 0. And by the way, if the degree in the numerator is larger than the degree in the, let's just say y equals here, the denominator, that means there's no horizontal asymptote. You have a slant asymptote. And that means you would just divide these two and get y equals x, which that's a linear y equals x. But for this video, we were just talking about horizontal asymptotes. So you only have to worry about if the degree in the numerator is, if they're the same, then you just divide the lead coefficients. And if it's smaller, then you just write y equals 0. And that's it. Thank you. Have a nice day. Bye-bye.